Okay, so moving on to other roots. So we have cube roots, we have fourth roots, we have fifth roots, we can have a millionth root if we wanted to. So we have other roots other than square roots. So we see this here, this 3, and then we write the root sign. That means a cube root. And we can generically have any kind of root. If I write n, let's put that a in there. If I have na, well, this is going to be the cube root of a here, and then n root of a is the nth root of a. So like I said, we can have other kinds of roots. So we already looked at square roots. We're going to talk about cube roots. And the rest of our roots are pretty much going to follow patterns very similar to square roots and cube roots. So number C is a cube root of a if the third power of C is a. Meaning C cubed equals a, or C to the third power, then the cube root of a should be C, which makes sense, like we see right down here. If I take 23 and I cube it, so 3 times 3 is 9, times 3 again is 27. Well, this also means, if this is true, then this is also true. This is an if or only a statement here. If that is true, then that means that the cube root of 27 would have to be 3. So there's something a little different that we see here with cube roots that we didn't see with square roots. So just going back to a square root, just a second, adjust something here. Okay, so bring up that square root. When we talked about square roots, one of the things we said is that we're always taking the positive root of a square root. We don't have two roots here, so we don't have to worry about a principal root and a negative root. So here we have a principal root, and we know there's a negative root. When we talk about cube roots only have one root. So like with 9, we know 9 has two possible roots. Either -3 or 3 is going to be the root. So either one of them, if I square it, gives me 9 back. In the case of cube roots, well, 27 has one root, has one cube root. And that cube root is just going to be 3. Because like we said here, 3 cubed is 27. So that means if I looked at something like -3 cubed, well, that's -3 times -3, which is +9, times another -3 gives me -27. So according to this then, that means that the cube root of -27 is in fact -3. So this is something we don't see in square roots, but can happen in cube roots. So 27 has one root, and also -27 has one root. Meant to write cube root instead of root root. Okay, so a couple difference here. Like I said, the square root, each root technically has a principal root and a negative root. We'll just really write the principal root. Also, I can't take the square root of a negative number in the real numbers, so that's something different. Cube roots, each root has one root, and I can take the cube root of a negative number. So we'll put that all together again here in a little bit. So first, we're just going to work on, just a second, my slide. It did a weird thing. I'm trying to circle back around here. There we go, cube roots. Sorry about that. So like I said, cube roots do not have a positive and negative root. They have just one root. It could be positive, it could be negative. If you're taking the cube root of a positive radicand, then it's going to be positive. The cube root of a negative radicand will be negative, like we saw here. Cube root of 27. 27 is positive, the root is positive. The cube root of negative 27, that's negative, the root is negative. So for any real number, a, then the cube root of a cubed is going to be a. What that means is that if I do the cube root of, say, 3 cubed, let's pick a different number there. I do the cube root of 2 cubed, well, that should just give me 2 back. And the cubed root of, so remember, the negative 2 is in parentheses, I'm cubing the negative. So in this case, like we have here, as this negative 2 is getting cubed, well, that means we get the negative 2 back. Make sure my slides are behaving the way they should. So just for an example here, so a lot of the rules that we have for square roots also apply here. So just to mention, any root of a product, we can split that product into 2 roots. And if we have a quotient, so the nth root of a quotient, that also we can distribute that nth root. So this also applies. Like I said, it's a product of the exponents, meaning it's a product of square roots. It also means the product of any root. So for a here, we have the cube root of negative 27 times x cubed. So that's the cubed root of negative 27 times the cubed root of x cubed. So the cube root of negative 27 is going to be negative 3, because we already discussed that one. And then the cube root of x cubed will just be x. So this is just negative 3x. So remember, I don't have to do absolute value here, because in this case, we're not keeping a principal. We only have one root to worry about. We don't have to worry about making sure it's a principal root. So b might not be as straightforward as you think. I'm going to turn this into a fraction first. So 0.008 is actually 1 over 125. So this is really just doing the cube root of 1 and the cube root of 125. So when you're trying to figure out what the cube root would be, one of the things you can do is just go through and take numbers. So like 2 cubed would be 8. 3 cubed, we already saw, is 27. 4 cubed is going to be 64. 5 cubed is 125. I don't think we're going past 5, so we'll stop there. Like I said, we can just keep writing all your cubes until you find that cube somewhere. So I see 125 here. Okay, well, that's 5 cubed. Let's put up here, 1 cubed is going to be 1. So the cube root of 1 is 1. The cube root of 125 is 5. And if I write that back down as a decimal again, that is 0.2. So the cube root of 0.008 is 0.2. We actually kind of expect this with fractions, that when we do the roots of fractions, we should get back bigger numbers. Or let's say that again. The roots of numbers less than 1 are going to be larger than the radicand. So C here, let's change my color. Well, I'll end up being the cube root of 27 over the cube root of 64. So 27, that's going to be 3. 64, that's going to be 4. So just take a moment and apply some of these rules to these ones. So we have the cube root of 64. Gonna end up accidentally telling you that one already. The cube root of x minus 4 cubed. So remember, we have this property. And then the cube root of negative 8 x squared over 125. So cube root of 64. Well, we see right here, here's 64, and that comes from 4 cubed. So the cube root of 64 is 4. The cube root of x minus 4 cubed, well, that'd just be x minus 4. And I don't have to worry about any kind of absolute values here because we only have one root with cube roots. C is a little bit more work because that's the cube root of -8 over, or -8 times x squared over the cubed root of 125. So this is still a product up here. So that is the cubed root of -8 times the cubed root of x cubed over the cubed root of 125. So we know that 8 comes from 2 squared, but we have -8. Well, if you do -2 times -2 times -2, well, that's going to give me -8, right? So -2 cubed is -8. So all you really need to do to change these is just put a negative here in here, and you can get the negative version of this. So the cube root of -8 is -2. The cube root of x cubed is just x. And the cube root of 125 is just 5.